Hello my dear students, welcome to my channel Research Chemistry Coaching. I think you are enjoying my classes, so let's start the second part of acidity of carboxylic acids, which are very necessary and it has lots of important questions in your term 2, as well as you get some questions in medical and engineering. Okay, now let's start. So acidity of carboxylic So acidity of carboxylic acid part 2. Okay. Now in my last class I have told you that presence of electron withdrawing groups such as nitro, cyano, benzene ring, halogens increase the acidity of carboxylic acids because removal of hydrogen positive ion becomes easier, and you know that presence of electron donating groups such as alkoxy groups, for example methoxy, ethoxy, such as alkyl groups, for example methyl, ethyl, they decrease the acidity of carboxylic acids because removal of H positive ion, that is proton, is difficult. Now remember it, presence of electron withdrawing or donating group affect the acidity of aromatic carboxylic acids. Do you know what are aromatic carboxylic acids? Listen now. Write down the question. How the presence of substituents affect the acidity of aromatic So write the question, how the presence of substituents affect the acidity of aromatic carboxylic acid. This type of question carries 2 marks. Okay, this type of question carries 2 marks. Listen, this is benzene ring. This is if the carbon of carboxyl acid is directly attached to the carbon of benzene, then this is called aromatic carboxylic acid. Its name is benzoic acid. When you insert substituent at ortho, meta or para positions, the acidity of carboxylic acid increases or decreases. Now for example, if we insert one nitro group at para position, so it is called para, this is ortho, meta, para nitro benzoic acid. It's called para nitro benzoic acid. If you insert one alkoxy group, or alkyl group, say you insert methoxy group. This is methoxy, OCH3 methoxy, OC2H5 methoxy. Okay, methoxy group. It is called para methoxy benzoic acid. So the question is how the presence of substituents on the benzene ring affect the acidity of aromatic carboxylic acids. Okay, if this type of question will come, at first see which substituents have electron donating natures, which have electron withdrawing nature. You know that nitro group has electron withdrawing nature, so it has electron withdrawing group. And alkoxy group, always put an arrow, okay, has electron, nitro group has electron withdrawing group and it is electron donating group. So directly write, if electron withdrawing group is present, then removal of H positive ion becomes easier, so acidity increases. So this is the strongest acid. And presence of electron donating group decreases the acidity as removal of H positive becomes difficult. So it is the weakest acid. So the decreasing order of acidity is this greater than this. Okay, so the decreasing order of acidity is, before that how to write the answer? Listen, presence of, if you want to write the answer, you have to write some explanation with order. Presence of electron withdrawing group, here nitro, increases the releasing capacity of H positive ion under bracket proton. Thus para nitro so write in this way, okay, because this type of question carries 2 marks. Presence of electron withdrawing group, here it is nitro, you have to mention, increases the releasing capacity of H positive ion, that is proton. Thus para-nitrobenzoic acid is the strongest acid. Okay, thus para-nitrobenzoic acid is the strongest acid. And in other sense, how to write it? Presence of electron donating group, here mention is methoxy, decreases the releasing tendency of H positive ion, decreases the tendency of H positive ion. So para para-methoxybenzoic acid. So para-methoxybenzoic acid is the weakest acid. In this type of question, okay, write also the order. Thus the decreasing order of acidity is, write the order also, okay. Thus the decreasing order of acidity. So this the answer, okay. Write the answer in this way. Now can you do some questions related with this? Let's check, okay. Tell me, okay. Whenever you watch the videos, okay, this is classroom type videos, so keep your pen and notebook and go with me, okay. It will be much more better than only watching. At first tell me which is the strongest acid. Listen now, it has no substituent. These two acids have substituents. This is called para-nitrobenzoic acid, and this it is called para-cyanobenzoic acid, okay. Para-cyanobenzoic acid, cyano, cyano, okay, para-cyanobenzoic acid. See, you know that nitro group and cyano group both have electron withdrawing capacity. I have given the arrow indicating electron withdrawing groups. This is also electron withdrawing group. It is also electron withdrawing group. In previous classes I have mentioned. Now, can you tell me which one has more electron withdrawing power? I have already given, today also I have told. Yes, good. Nitro has more electron withdrawing power than cyano group. So this is the strongest acid and it is the second and it is the least acidic. So how to write the order? If you mark it 1, if you mark 2, if you mark 3. So the decreasing order of acidity is 2 greater than 3 greater than 1. See the question, decreasing order. You have to arrange in decreasing order. Now, next question, okay, write it. Next question. Same heading, okay, arrange the following in decreasing order of acidity. Sometimes they may give in decreasing order, that is descending order. Sometimes they may mention increasing order, that is ascending order. Whenever they give decreasing order, then write highest acidic to least acidic. If they mention increasing order, so least acidic to highest acidic. Remember it. Next question, okay. This is para-methoxy benzoic acid. Write the name, okay. Whenever you practice organic chemistry, write the name always. And it is, anyone? Good. Para-methyl benzoic acid. And it is obviously para-chlorobenzoic acid. Para-chlorobenzoic acid. Now, next part is mention which group has electron donating nature and which group has electron withdrawing nature. It has electron donating nature. It has electron donating nature, halogens electron withdrawing nature. Now, it has electron withdrawing nature, okay. It is electron withdrawing group, electron donating group, electron donating group. Mention it as 1, it as 2, it as 3. Now you know that if electron withdrawing group is present, the acidity is the highest. So 3 is it has the highest acidity or strongest acid. And it has also electron donating nature, it has also electron donating nature. Now see, if electron donating group is present, the acidity decreases, you know. Which one has more electron donating nature? That acid is the least acidic. This methoxy group donates electron, okay. The methoxy group donates electron by inductive effect, that is plus I effect, and as it has lone pair of electron, it also donates electron by resonance effect. Plus I indicates that it donates, so it has shortage of electron, plus by resonance it gives electron, so it has plus. Methyl group donates electron by only plus I effect and some extent of hyperconjugation effect, okay. Later on I will deliver a lecture on hyperconjugation and resonance. So it has more electron donating power due to the two effects. One is positive inductive effect, positive resonance effect. Positive inductive effect and another is positive resonance effect. Thus it is the least acidic. So mentioning it is the least acidic. So how do you arrange the acidity in decreasing order? So the highest acidic 3. So the decreasing answer is, so the decreasing order of acidity 3 greater than 2 and greater than 1. Okay, 3 greater than 2 and greater than 1. So decreasing order of acidity is 3 greater than 2 and greater than 1. Clear? I think everyone is clear. 3 greater than 2 greater than 1. Now the next question, do it. You do the question, okay? The next question, you do it. Question. Do the next question, okay? This is very important question, okay? Now, same type of question. Arrange in decreasing same heading, okay? Arrange in decreasing order of acidity. This is important for entrance also, okay? This is important for entrance also. So interesting here, all the substituents are same, but their positions are different. It is in ortho position, it is in meta position, it is in para position. Ortho nitrobenzoic acid, meta nitrobenzoic acid, para nitrobenzoic acid, okay? Just try it. Can you say me which is the strongest acid? Nitro group has electron withdrawing nature, okay? Nitro group has electron withdrawing nature. So mention electron withdrawing, electron withdrawing, electron withdrawing. Position is the main thing. Nitro group withdraws electron by minus I effect as it withdraws electrons, so it gets negative charge, so it is minus I, negative inductive effect as well as resonance effect. Because why nitrogen has resonance effect? Listen now, if you draw the structure of nitro group, the nitrogen which is attached to the benzene ring has pi bond. Any atom whenever attached to benzene ring contains pi bond. Pi means double or triple bond. It always attracts electron towards it by resonance. Remember it, okay? Whenever I will deliver a lecture on resonance, you understand. At meta position, there is no resonance effect. Remember it. Resonance effect is applicable only at ortho and para position, and also remember it, at para position resonance effect is the highest. So write it, okay. Nitro group has electron withdrawing group. It has electron withdrawing nature. It withdraws electron by, anyone, just now I have told you, good, minus I effect, negative inductive effect. Why? Because whenever it withdraws electron, it possesses negative charge, okay. It gains electron from the ring, that's why it becomes negative charge, so it is negative inductive effect. As well as negative resonance effect. And remember it, the resonance effect is the highest at para position always. Whether it is electron donating or withdrawing, resonance effect has the highest extent at para position. Write it, okay. I will erase it. So remember it, resonance effect is highest at para position. So write it, resonance effect is highest at para position, okay. Now hence you can say that it is the strongest acid, it is the weakest acid, it is the second position, correct. So just tell me the decreasing order of acidity. Mark it as 1, 2, 3. So I know that you tell me the strongest acid is para-nitrobenzoic acid. So the decreasing order of acidity is very easy, 3, because it has resonance effect at para position greater than 1, because resonance effect is applicable at para position and only ortho position, no meta. So meta is least acidic. Clear? But remember it, this is wrong. That's why it is important. In chemistry, there are lots of exceptional and extraordinary conceptions, and that's are only entrance questions, okay. Now right, what is the correct order here? And this is very important, okay. Remember it, this is called ortho effect. Write the notes and I will give the answer, okay. It is ortho effect. In aromatic carboxylic acid at ortho position, whether there is electron withdrawing or donating, I repeat it, that acid is the strongest acid. That's called ortho effect, okay. Write down, okay, in aromatic So remember the ortho effect in aromatic carboxylic acid. You know that acids containing directly carboxyl group attached to benzene called aromatic carboxylic acid. If electron donating or withdrawing group is present at ortho position, then it is the strongest acid. It is called ortho effect. It is called ortho effect. I know in your mind a question may arise. What is the reason behind it? Listen, later on, whenever I will give a lecture on resonance, it will be clear to you, okay, because it is directly attached to the resonance. Thus, it is the strongest acid. It is the strongest acid due to ortho effect. It is the strongest acid due to ortho effect, and it is the weakest acid. Interesting question, isn't it? Very important. So the decreasing order of acidity is, thus the correct answer is 1 is the strongest acid greater than 3 greater than 2. Okay? Now I think you understand it. Next question. Same heading, okay? Arranged in decreasing order of acidity. Same heading, huh? Question. Write it, okay? Mark it 1. Arrange in decreasing order of acidity, okay? Arrange in decreasing order of acidity. Decreasing Can you tell me which is the strongest acid? I know you say, sir, methyl group has electron donating group. It has electron donating nature. It has electron donating group. It has electron withdrawing nature. So I know you say, sir, it's very easy. 3 is the strongest acid because it has electron withdrawing group. But wrong. 3 is not the strongest acid, though nitro has electron withdrawing nature. It withdraws electron by minus I or minus R, but it is wrong. Now this is ortho effect. So remember it. Whenever any question will come, whether in board or in entrance, always see if it is aromatic carboxylic acid, whether there is any substituent at ortho position or not. If the ortho position contains electron donating or electron withdrawing, that is the strongest acid due to ortho effect. Okay, so the answer is, this is also very important for entrance as well as board. Actually, ortho effect I have seen rare in board exam. So, one is the strongest positive inductive. Strongest acid between the two, it has donating, accelerating, so obviously 3. So remember it, my every classes I deliver lecture on topics is a classroom type. Whenever you want to watch my videos, please keep one pen and notebook with you so that go with me directly, you understand much more. And the last question, okay, on acidity of carboxylic acids. So the last question on acidity of carboxylic acid question. Arrange the hydrogen atoms in arrange the hydrogen atom in decreasing order of acidity. This hydrogen I have marked as 1, say it is 1, this hydrogen is 2 and this hydrogen is 3. This is the last question, okay, please remain. So arrange this hydrogen as decreasing order of acidity, okay. Can you arrange it? Can you tell me which is the strongest acid? It is carboxyl acid group, it is phenolic hydrogen and it is alcoholic, primary alcohol. So listen, this is aromatic, it has aromatic, this is aliphatic because the OH group is not directly attached. So remember it, aromatic hydrogens are stronger acidic than aliphatic. So this is the least acidic, this is aliphatic, this hydrogen is aliphatic because the OH group, this is actually aliphatic alcohol, not aromatic, remember it. There is one common mistake of most of the students that if benzening is present and it has substituent, then always aromatic. No, this OH group is not phenolic hydrogen, this is the alcoholic OH group and it is aliphatic in nature because the OH group is not directly attached to the benzene ring. That's why, and you know that aliphatic hydrogens are when attached to benzene is the least acidic. So it is the least acidic. Write down hydrogen 2 is this hydrogen, okay, least acidic. As the OH group of this CH2OH is an aliphatic alcohol. So write it, hydrogen 2, this is the least acidic, as the OH group of CH2OH is an aliphatic alcoholic group. Once again, the OH group C is not directly attached to ring, so it is aliphatic nature, least acidic. This directly attached, this group, so it is aromatic in nature. Now, I think you have written it. In between the two, this is phenolic hydrogen, because the OH group is directly attached to benzene, called phenolic hydrogen. This is carboxyl group. Now, can you tell me, phenolic group or carboxylate group, which is stronger acid? Very easy. If you draw the structure of this, don't draw, now just listen. Oxygen, due to more electronegativity, attracts electron. Okay, that's why there is a resonance effect. So due to resonance, this hydrogen releases easily. No need to write, only listen. This between the two, hydrogen 3 is the strongest acidic of COOH group. As due to resonance, that is minus I, removal, write it, okay, removal of H positive becomes much more easier. Write it. Last, okay. I think you have written it. So it is the strongest acidic it has the least acidic. Thus the order of decreasing order of acidity of hydrogen is thus the decreasing highest acidic hydrogen 3 greater than phenolic hydrogen 1. Okay, so thank you for watching this. Next day, in my next videos, I will discuss on nucleophilic addition reactions of aldehydes and ketones. Okay, please watch it. Before the turn to board exam, I will give 10 classes which you please see, because I will suggest the most important questions, answers with discussions. Clear? So thank you for watching this. Bye.